All right, so this is the second section of solving partial differential equations numerically. Particularly, we were doing example 8.1 from chapter 8. And so we're going to continue doing that. Go back to here. So I was explaining how we can color code our solution. Let me just go over it one more time. So I'm going to maybe clear the coloring here. And to do that, let me just go to conditional formatting and then select this guy and remove it. All right. So, okay, let's go back here. All right. So we said we're going to start from this corner, second column, second row in time and position. And the reason is because for the first column, we know it from boundary condition. The first row, we know the solution that's given from the boundary condition. And this is the first cell that we don't know. So what we're going to do is we're going to basically implement this equation right here. J means previous row. J plus 1 means, so think about it, J plus 1 means if you think of J plus 1 as the current, then J would be the previous row. Okay, so if I'm sitting here and I want to calculate this cell, I'm sitting on column J plus 1. Okay, I'm sorry, I'm sitting on row J plus 1. So think about it as so J is the row index, right? J is the time index, and time is going along the column. So that means from J to J plus 1, I'm going from this row to this row. Okay, by moving down along the rows, you're increasing J index. And by going from left to right along the columns with the same row, you're going from, let's say, I minus 1 to I plus 1. You're increasing the I index. All right. So again, I is the column and J is the row. All right, I'm sitting in this. So that means I'm looking at this cell. I want to calculate the value for this, and that's linked to UI and J. So as soon as I see J, that means previous row. Okay, so this guy is equal to same column, same I index, right? Same column, previous row, because this is J, this is J plus 1. So same column, previous row, which means this cell. Okay, and that's why it's blue. So it's C4, which is exactly UIJ. And then plus this one, I calculated already. It's right here. Is d theta over dx squared is 0.4 times the parentheses. So here is this guy times the parentheses. The first element is I minus 1 and j. So if I'm sitting on this cell, this means previous row, because this is j and this is j plus 1. So previous row, previous column, because this is I, this is I minus 1. So you're sitting here, previous row, previous column is the purple guy. And right here is purple, it's B4, corresponding to UI minus J. All right. Next, minus 2 times UIJ. Okay, so you're sitting on this and you want to calculate, you want to access this. So from here to here, it would be same column because it's the same I, same column, previous row. So you're sitting here, same column, previous row is going to be the blue cell, and that's my minus 2 times C4. So this is C, right, C4. All right, next, I plus 1J, with reference to this, is going to be next column, previous row. So you're sitting here, next column, previous row. It's going to be the purple, or the brown. So it's going to be the brown, it's right here, D4. So we just wrote this equation exactly into the spreadsheet. Okay, you hit enter. Done. So that's the only cell you have to do. This whole problem depends on this very same cell. So if you do this wrong, everything goes wrong. If you do this right, everything goes right. Okay, so that's it. So you're going to drag it all the way to here and drag it all the way down, or just double click on that. So we solved the problem. We solved the numerical. We solve the differential equations numerically without knowing what the analytical solution or exact solution is. So this is really beautiful in Excel. You can just everything is this guy. this only one cell can solve the whole problem. All right, so I'm going to show you very quickly how I can color code this. So this is basically temperature distribution, right? And one way to look at this is we're going to color code it such that higher number becomes red and lower number becomes blue, exactly like hot and cold. Hot is red, cold is blue, right? Low temperature is blue, high temperature is red. So we're going to color code this without going to every cell and say, oh, this is 1, it should be red. This is like 0.8, should be, a little bit bluish. And maybe this is very low number, small number, this should be very blue, right? I don't want to do that. I want Excel to do this for me. Okay, so watch here. I go to the same cell that I implemented my equation. Then I go to top menu here in Mac. Most likely you should have similar thing in Windows. I go to Format and go to Conditional Formatting, right? Conditional Formatting. I'm going to go to that. I'm going to click on plus. I want to add a rule here. So here's the rule. I'm going to use 2 scale bar. I'm going to go from blue to red. It's a 2 scale bar. A 2 color scale. And then here's the lowest value. So the lowest value I'm going to put blue. And the highest value I'm going to put red. That's it. You hit enter. It puts in here. And then you ask you where you want to apply this. Okay, if you want to apply it to the whole thing, then you have to give the range here. Like I want to go from here, you can highlight the whole box. Okay, like here I can click on this and then go to here and then go down by dragging my mouse, go all the way down to wherever you want to highlight. So this thing goes down, I think I'm up to time equal, I have to be really fast. I think there's 1,000 lines here. Yeah, so you have to scroll it all the way down. So I'm still going down. So about 1,000 lines here, man. Okay, so still going down, faster, faster. Yeah, so I'm still holding down my mouse key. Yeah, going down. Oops, I screwed up. Have to go this way. There you go. And then go down. Okay, so this takes time. I gave up. So I don't want to do this way. So the way you do is you go back up again. And you only apply to this cell. So let's say I'm going to clear this up. Just apply to this cell. You hit OK. Alright, so this cell is color coded. Well, there's one cell only, so there's no minimum maximum to scale between blue and red. But let me just drag this guy one more time to the left. Sorry, to the right. And you see that now it actually color codes it properly. So now one is blue, one is red, and 0.6 is blue. Nice. So now when you just double click, it applies it to everywhere. There you go. So you don't need even to drag all the way down to 10,000 or 1,000 lines. So here we color coded it. So you can easily see the temperature distribution goes from blue to red for every. Let's say I'm looking at this time. Right, by the way, here's the cross section from this plot. This one is, let's see. This is at T0. So at T0, here's the temperature, here's position, and I'm plotting this row, the first row, sorry, the second row, okay, against the first row. So first row is X, second row is the temperature at T0, right? So I'm plotting temperature T0 against X, and that's the blue line. So initially this is ice, temperature goes up and everywhere is hot. All right, now we go to a little bit further, that's T equal 0.001 or 0.01. So 0.01 is, let me just click on that. It's this row, right? So I'm plotting this row against the X values are right here. You see that? So this row, which is at time 0.01 against the first row. And you get this temperature distribution. So this point is on ice is always 0, but temperature quickly rises and it gets to about 1 from this point on. And when it gets to the other side of the rod, is temperature, well, the temperature is still 1. We go further down along the time axis. Let's look at the time called 0.1, and it's going to be this. So 0.1 on my spreadsheet is way down here. So I'm plotting this column, which is the temperature distribution at this time, which is 0.1, against my x values, which are up here in the first row. And that's going to be the green curve. Okay, and you see the temperature now is going up still, but now these points that used to be at temperature 1 have lower temperature. Temperature is actually going down everywhere except the last point, because we put it on a, let's say, on a heating source. So temperature is hot here, or here's hot, here's cold, and temperature is slowly going down everywhere. And here is a temperature distribution at t equal 1, like 100 times longer than the first one we looked at. Okay, and this is the temperature distribution. It's linear, and that's going to be last row in this box. I'm not going to go down, but if you go down this along this box or block, at the end you have a row. So I'm plotting that row against x values, right? So here's x values, and you get this temperature distribution. All right. This is on Blackboard, so you can go and play with it and look at it how I wrote the equations, look at the coloring, click on the curves and see what I'm plotting and stuff like that. Okay, so the point was we solved differential equations, a differential equation which depended on time and position, particularly when you look at heat distribution or temperature distribution along the rod, in which one end was on ice, the other end was on heating source, and initially everywhere is hot, and we look at how temperature varies in time. So this is actually time varying temperature. Initially we got the blue curve, after a few seconds we get this red, after a few seconds we get this green, and after a few seconds we get this purple line. Okay, there's a lot of learning here. You learn how to do the color coding, you learn how to solve differential equations that depend on two variables. Let's say in this case t and x. We're going to look at other techniques and other differential equations in the next coming videos. Alright, so thank you so much for watching, and stay tuned for the next video.